Apple introduced during WWDC25 the new Foundation Models framework, which allows you to use the local LLM in your own apps. This is the same model that powers Apple Intelligence. In this tutorial series, I'm going to give you an introduction. So we're talking about requirements, what devices to use, how to check if we actually have a local LLM. And then we dive deeper in a specific use case. This is important because I not just want to have a superficial demo project, I actually want to see if this is production ready. For this specific use case, this requires a lot of engineering and testing of different prompts, instructions, how we can enhance the model's capabilities with tool callings. This is then in the second video. And some more advanced things on the go. And the app we're going to work on is a little dog helper. This is the initial screen where you can decide from a list of questions. It's a good idea to have a couple of questions to ask so we can continuously test and see what's working and what's not. For example, you can ask, tell me about the dog breed Border Collie. Now, the local model that they shipped does have some knowledge about Border Collies. And you see now it gives me this information. But I'm actually enhancing this with tool calling. That is, for example, when you test the local LLM and it has some limited knowledge, you just want to enhance it so we can pass it more information. For example, the rather unknown dog breed Caracashan. In this case, the local model does not know about it and really relies now on the information I'm providing with this tool calling. So this is a large dog. It's a protective dog for sheep. This is now only using the information I'm giving it. So we can work on enhancing these tools. But I can also do stuff with this tool calling, like look for specific criteria. In this case, I have here what dogs are allergy friendly. So now I use the tool to fetch specific breeds. It's giving me poodles because this is the one that I gave it. In order to make this work, we need to look at what prompts the user uses, deciding what intent they have, what to return them. And you might also want to tune how much the response is giving back. It could have here written like 500 word essay. You might not want this, or you want to have more shorter responses. You will see some example where how to do this. Now, the way you interact with this model is not just one prompt and then back. You can also do chats, continuously ask questions. In this case, it already knows. Here we're talking now about poodle. So I can say, are they also good with children? In this case, it shouldn't understand that I'm talking here about poodles. Sometimes it works, sometimes it doesn't. And you see, it tells me, yes, poodles are also good with children. So you can continuously ask questions. And then with this restart button, we can restart a new session and start this from the beginning again. You can find the link to this project in the video description, so you can download it and try this yourself. Before we go into more specifics, I want to clarify a few things. First of all, the availability. You need to, if you want to test this, run this on the device, you need to have a test device that is running iOS 26, macOS 26 like Tahoe. If you want to do this on the Mac, you need to then on the device also enable Apple Intelligence, which will download the model, which is around 3 GB. This might take a half an hour or a little bit, so you might need to wait. So if you have macOS Tahoe on an M1 with Apple Intelligence installed, you should be able to run this in the simulator. If you want to test this on a device like an iPhone, you need to have a newer iPhone that's a 17 Pro chip or newer. So for example, iPhone 15 Pro and then the iPhone 16. If you, like me, have an iPhone 13 mini, it's not going to work. Again, when you have it on the device installed, you then need to enable Apple Intelligence in the settings so that it downloads the model. You can also test this for an iPad with a 17 Pro chip like the iPad mini, the newer ones, or one with an M1, M2 chip. Again, for Mac, it needs to be an M chip series, so Intel doesn't work. You see here some of the devices that don't have this, like the Apple Watch, the older iPads, Mac, Intel. This, as you see is quite limited. The obvious question is how many devices would be eligible to run these, so you know what to expect when you launch an app in September that uses the Apple Intelligence or the Foundation Model Framework. I used ChatGPT to do a rough estimation. So if we estimate that around 1.4 billion iPhones are there, and the newer ones for iPhone 15 Pro is around 7%, and then for the 16 plus the 16 ones, maybe like 15% of the iPhones are potentially running the new foundation models framework. That's not a lot, which is why you need to really then in your apps make sure that you're checking for the availability and give the user feedback. The percentage for the iPad is higher because of these M1 chips that have been shipped for quite a while for the Pro ones. So you have like 20-30% of the iPads that might run this. This also you need to consider, for example, if you have an app for schools, for students, they usually run one of the base iPad models, which don't have a newer chip, which will not be able to use Foundation Model Framework. So just have a look at your use case and if they actually have the right iPad for this. Or if you have an app for something like photo editing or some creative photo editing or video editing, these usually are users that have a Pro one, an M1, so a higher level iPad, which then are more likely to have Apple Intelligence. For the Mac, the M1 series is really popular. So here the estimation is maybe 50% of Macs, and I'm pretty sure it's going to get quite fast away with the Intel Macs when they don't support it next year anymore. Although obviously there's more iPhone devices there, but just so you know what you're getting yourself into, let's now have a look in code how to check what device is actually eligible for. This is the starter project that you can download together with the final project. And here in the main app file, I'm just generating another struct, liability view. In order to check this, I need to import the new framework, the Foundation Models Framework. The reason why it's named like this is in the AI world, a foundation model is a base model. It's a general purpose model that you can fine-tune or change for certain use cases. With the model provided from the device, you can also use adapters to add a small layer on top for specific use cases with fine-tuning. These models are called foundation models because they are general purpose models. Large language models for different kinds of things. A general knowledge from the World Wide Web and the whatever they use for training data, we don't know. So just don't confuse it with the foundation frameworks. Now in this view, what I actually wanted to check is the availability. So private var model, this is the system model default, giving you the base version of this model. And this has a property which is availability. So you can also check supported languages. This is in a set of locales. There are 12 languages that it supports. So you can also use this property to say, oh, your language is not supported. Or you just check is available. Now we want to have a little bit more information. You will see in a minute. We are going to use a switch models availability. So we see all the available reasons. The first case is available. This is good. Basically, we can just proceed as normal with everything. Now for this app, the whole thing doesn't really make sense so far if we are not having the availability. So in this case, I can just return the content view, the normal view. And for the other ones, I'm telling it not just the other information so they can't proceed. Then we have an unavailable. And here you have 3 different cases. So we have model not ready, device not eligible, Apple Intelligence not enabled. So let's start with model not ready. This means the device is capable of Apple Intelligence. It's just not ready yet because when you enable this Apple Intelligence, it needs to download the model, it needs to do a lot of setups. This can take half an hour. Basically, We want to tell the user to come back a little bit later because it's not ready yet. So you can tell the user, the model is not ready yet, please come back later. Then the next available reason is Apple Intelligence not enabled. This means the device is capable of this, but they didn't enable Apple Intelligence in the settings. We want to kindly ask the user to enable this. So something like Apple Intelligence is not enabled on this device, please turn on Apple Intelligence. The last case is device not eligible. So this means it's an older iPhone. For example, from my iPhone 13. This would be the message that I will then see. So device is not eligible for Apple Intelligence. We are sorry, we can't provide you this feature because your device is not new enough, not fancy enough. And I think there's one more for other. So in this case, I guess this is the one of the unknown reason. Okay, now that we have these cases, so you see there's quite a few possibilities. I'm going to use this view on the root in my Chatbot app. If everything is okay on the device, you will see the normal content view. Otherwise, you will see one of these help information. Okay, I'm going to now use one of my simulators. And you see I have the correct information. Now, because we don't want to do some weird stuff or test, you might want to test if this is really shown here, these cases are fulfilled. And I added under your projects, edit schema, and run, options, scrolling down. There's one simulating foundation model availability. Now just checking my normal system. And here you can say device not eligible, Apple Intelligence not enabled, or model not ready. These are exactly the reasons we just went through. So you can now choose one. Let's say Apple Intelligence not enabled, close, and now I build and run again. You see this time we are starting with this help message. This is a trick to test this in case in the future you want to run this and you're not sure why it's not showing up. I am now going back to my edit schema, options, and I'm turning this off so we can continue properly with our tests and running these models. I prepared this project to have this small view model where we're going to work on the send message function. But before we do this, I want to show you some simple first tries. Here I'm going to use a playground, importing playgrounds. This is similar to previews now. The playground macro, where we can run some code, not just views. Need to first import the framework, foundation models. I want to quickly run some prompts to see the quality of this model. The type we are mostly working with is the language model sessions. You can give it multiple prompts and it returns for each prompt. So each session is like multiple prompts and responses. I am starting with the default initializer and then we're going to customize this a little bit more later. I can define a prompt. For example, what is the meaning of life? Then you can run this model with this prompt by using the session.response with this prompt. This is an async function because it's going to continuously... Okay, the initializer is to prompt. I didn't want to use the closure one. So this is the response. The response function is an async throwing function. Async because it needs to, in the background, generate this response. So it might take a little bit, which means we need to await this. Now this also can throw. So this should be then try await. And I'm going to catch the error so we see what things can go wrong. And I'm going to also print the response. Now in this case, the response the type that we get back, the string that I want to see is actually the response's content. Okay, now I can open the canvas. So it's actually going to run this. Whenever you run this model, like I do now on my Mac, it will use the LLM that it's downloaded for my Mac, which means it will run with the performance of my Mac. This is another thing to keep in mind. You see now on the right the new playgrounds area where you see all the properties that I defined in the prompt. Once it's finished, you see I get the response back. The string here is the one coming from this response. And here also my print statement. As you see, it generated a little bit more because I maybe went a little bit overboard with what is the meaning of life. The full duration for this generation is 23 seconds. For this kind of philosophical questions, it's probably not the best model because it's not good at argumentation and human interaction. So this kind of philosophy is probably not a good idea. I try to use it as a cat philosopher, story cat philosopher. It's not as sneaky, sophisticated, interesting as a conversation with this as compared to when I tried with ChatGPT. So this is not a good use case. What you also need to look out for, just because we're already here with these errors, what are the types of errors you can get? And these are usually guardrail errors. This is definitely not something you want to use in your app to respond. And you see we get a generation error with the description may contain sensitive or unsafe information. And the type here is a guardrail violation error. So this is a special generation error that you can have a look at. If let error as generation error. Let's try this again. I forgot the full type. This is this is the couldn't be completed, and the generation error type is 2. Let's just jump to definition. So you have an idea of what are some of the problems. We have the exceed context window size. This means in our discussion here, if you continuously go on, at some point you're exceeding the context window, which is 4096 tokens. It's not so long because the reason why they choose to make it smaller is so that it runs faster, so that there's a compromise of speed and context window. Then we have assets unavailable, guardrail violation. This is the one we just saw. It hits it really quickly for things I think are not necessary. I guess they did this more sensitive to make sure it really worked. Then we have unsupported guides, unsupported language or locales. For example, the user prompts in a language that is not supported, something specific, something that is not included in one of the 12 languages, then you get that error. Decoding error. Rate limited. This only happens when you're running the app in the background. Maybe you're processing something and you're using the local LLM. The system is trying to optimize between your app and the one that is in the foreground. So then, because the foreground one is more important to the user, it will prioritize this one and it will throttle your app in the background. Concurrent requests. When you have a session, you can only do one prompt generation. So we need to also check that we don't add another generation at the same time. Now, this is per session. You can have multiple sessions, multiple chats, simultaneously asking for different things. So this is a way of getting around this. Then they added here recovery situation and failure reasons. Okay, so this is a little bit to errors and some more specifications about these models. So just a quick overview of the model specifications. We have a large language model with 3 billion parameters, not the biggest. If you compare this to like ChatGPT, like 4.0 or Claude Sonnet, they are more like in the 100 billion. This one is on device. The reason why they choose 3 billion is it's roughly the same in RAM and gigabytes. So this is like, you can run this if you have, it will take up 3 gigabytes of RAM. And the newer iPhones, for example, have upgraded from 6 gigabyte to 8. That's why they can run this. I guess otherwise these models are too small and not reuseful. Then, as said, 15 languages are required. When the user prompts in their language, the LLM will respond in this language. The cutoff time is end of 2023, so you should not use this for newer information. This is text only, so you cannot inject any images. This is for small text-based enhancements of your apps. However, you could work around this. For example, if you have an image with some text inside and the user asks for like scanning a document, you can first use the vision framework to extract the text from this image. Then you take the text and pass it in the prompt to the LLM, to the foundation model framework. And then you can continuously work on this. This should be a very good workflow because you get the best of both sides. Vision is really good at text extraction and the foundation model framework is really good at prompt. For example, you can use a PDF, scan a PDF, scan a document, and then extract certain informations. Like for a recipe app, you can take a picture of the recipe in a book and then format it and show it in the app. Now, because of these specifications, it's not a good idea to use something that is aimed for world knowledge or advanced reasoning, because it's so small. It has some information and you should, when you start out working with it, just prompt it a couple of things, what it knows and what it doesn't. Or if it is lying or if the information is not what you expect, then we need to work on this. Because of this limitation, it's somewhat very limited for the use case we're having now with this chatbot. The reason why I think it works is because it's asking for knowledge base. It's not a normal conversation. Other things I found very good for summarization, structured extracting information, so small things. Like I said, for the recipe app, it would then extract from the image, from the text, the ingredient list of how much of each ingredient. So you could have a proper list. You can do classifications of, for example, for this recipe, is it an Italian recipe? Is it a pizza recipe? Is this for cooking, baking, sweets? For this, it would be also quite good. For the content generation, it's somewhat limited. You really need to test it because sometimes it makes logical mistakes that don't really work. If you use it for quiz generation, it should not be like advanced math or university grade quizzes, but more for simpler ones for school, 5th grade or something. Okay, this was a little background. The use case we are aiming for is for pet information one for dogs. So when you look at your use case, just ask it here, for example, can I keep a Carcassion is a Bulgarian mountain dog, which definitely should not be held in an apartment. Unless you're Putin and you have a palace. They're quite big and very protective. I use this because it's a very special breed and the LLM does not know about it. Wonderful companions for apartments, so it's now hallucinating. Definitely not what you want to do. For this specific use case, we're going to use a database entry to feed it back so it understands and gives proper information. So here it's hallucinating, or sometimes it doesn't know. It has more general information, like for border collies. Can I keep a border collie in my apartment? It's probably going to say no. It's a question of, is it either general knowledge, what people say on Reddit or on the internet, and maybe you have different or more information that you want to give, then you would also want to change the response. Holding border collies in a pod can be challenging. However, it is possible. Here, in this case, you would want to change the response. It is somewhat accurate, but maybe not the way you wanted to respond. Now, the reason why I choose this example is, well, it's also more fun. But you can imagine that you want to have a little chatbot in your app, for example, for help, how to use your app, how to navigate your app. You can also use this in these cases. So there's quite a few use cases with chatbots. Next, I want to talk a little bit about the model parameters that we can use. This model session has a couple of parameters, so you can specify a different model. So there's a default one, but you can also add a fine-tuned layer with adapters. You need to train this yourself and continuously train it with each iOS update version. So going from 26 to 26.1 to 2 to 3, they will have different models. They might have different models that they are shipping. So you need to then train your adapter again and again. It also means that when we do all this prompt engineering and optimization, you need to also keep in mind that the model might change in future versions. So you need to continuously monitor this. They have a different model adapter for content tagging. This is for something like categorization. For the recipes, is this a pizza recipe, a baking sweet, salty? Then you would use this use case. In this case, we're just keeping the general, the default. Then you can here add guardrails. As you saw, there was quite a bit of problems with the guardrails. I mean, I had quite a bit of errors with guardrails. I don't know if I can actually pass a custom one yet. Right now, I can only set the default one. I guess they want to make it rather strict and safe, so people are more careful. Then the next argument is tools. So you can define your own tool. This is the next video tutorial where I add here a tool. That means during the response, the LLM will take the user prompt, ask the tool for additional information, retrieves this, and then uses this additional information to respond to the user. And the last one is instructions. So let's just remove these because I am not actually using them. So instructions are what you want the model to behave in general. The instructions are provided by you, the developer, to tell the LLM how to respond. So in this case, because I said we want to have a dog helper app, I use something like, you are a dog specialist. Your job is to give helpful advice to new dog owners. As you see, the prompt changes quite a bit with a shorter response. You can change the output. We go to this a little bit there later. But the good thing about these instructions now is that it will take these into account a lot more than the user prompt. For example, maybe someone is going to use your app with and they try to disuse it. For example, what is 1 + 1? This is not a dog-related question. And you see the response of the model is, I'm sorry, I cannot assist with that request. If I remove the instructions, it would return the proper response. So you can make sure that the user does not use your app in the wrong way. So the instructions, it takes into account very strongly, even if the prompt is different. The prompt will come from the user. Now, the other settings you have is with the response. So use this again. Use things like schema. This is the custom schema. This is for guided outputs, for structured output. The one that might be still interesting here is the generation options. This is options where you have the sampling. This is, for example, greedy, which reduces the temperature to 0. It basically means don't be creative at all. Just give me the most likely output. Now, if you use this, it's not going to respond in a human way. For our little chat app, this is the wrong setting. It's going to sound even more like a robot. I'm using the default one. You can additionally change the temperature. This is the creativity of always use. If you change the temperature to 0, it will always respond in the same output. For our app, maybe we want to have some variations. So you can go for 1 or 2, although I tried 2 and it's getting random. It's too high. It's too chaotic. Lastly, you can change the maximum response tokens. If you only want to have 200 tokens per response, and this is not the one to use because once it exceeds, I'm just going to cut off. So it might cut off half sentence and you will get an error. Not the ideal one, so, but you can still use it. In this case, I'm leaving it open. So we're using these settings. A better way of shortening this is adding words like in, EU words. You can also do in 100 to 200 words. In detail makes it longer. In 2 paragraphs makes it shorter. As you see, it's taking longer because the generation is longer. This leads to the next question. We'll wait for the complete generation of this whole text. This is not a good way for using it on our app. We want to stream the output. In this case, we don't use the response function. We're going to use the stream response. So you can again use the options or just to prompt. This is a stream. This function returns a response stream with strings inside because I didn't specify what type I want to return otherwise, so it's returning strings. Now we can use a async stream for try. This is again because it can fail during generations, like I said, context exceeded or something. So this is try. So every time there's a new token generated during this streaming generation, it will go into this loop. This partial is a partially generated return type for strings. And it's not like it returns you these tokens one by one. Every time this is called, it gives you back the whole text string up to the newest point for the next loop with the next word included. Make this a little bit bigger. So it now outputs it every time there's a new one, and it every time outputs it here, the full text. So this is the one we're going to use then for streaming it to the UI. Now let's have a look at our view model. When this send function is called, we need to use the user input and pass it to the session. For this app, in the initializer, I'm going to set up the session and store this as a property. So this is private var session of type LanguageModelSession. And in the initializer, LanguageModelSession with the instructions, we're going to use these instructions. And I'm going to store them as a private property because we need to use them a little bit later again. Now, when I want to send this message, I can do the same as I did here with this do catch block. Instead of this prompt, I use the user input. As you see, this is a async function. You could make this function await, but I want to do this in the background. So I am passing this as a different task. This is also because I want to reset this at some point. Okay, now this is happening in the background. And I need to do something with my partial generated result. So up here, I create a property, partial. This is string partial generated optional. This is a little bit of a strange type, but you will see that it helps us by keeping this. We can nicer animate the UI and keep it more responsive and better performing. So now every time I get a new partial result, I set this to my partial. Let's see how we can connect to the UI for a first basic one. In content view, I have here this instance of this view model with this partial generated result. I have the suggestion view, which is shown when there's no messages, and this chat view. So I want to actually show this in the chat view, which means I need to add this here. So this is the same type, string partial generated type, which means I need to import the foundation models framework. Optional. Here I have a lazy VStack with the already generated messages, and now I am going to show here this partial generated result. Now I get a few errors for the initializer. In these previews, I'm just going to pass nil. I'm here returning an empty one for now, just so we see something. Back in content view, I need to also pass this from the view model in order to actually see something, because I have here this if-else statement. It only shows something when I have one of the messages. Before this task, I used the user input to generate a new message for this message array. Append chat message. So in this case, it's the user, and this is the user input. So I have one message, so we actually see the chat messages. So, for example, which breed don't need a lot of exercise? And you see we get the response in the streaming output. Now it returns me this in Markdown. This would be in bold. And it looks a little bit choppy generating this. So let's do some fun exercise before we go more into the boring, making this more stable task. So I added here a little Markdown text view. You can use text view with localized string and then pass the Markdown to get a formatted Markdown. It does not look nice with lists, so that's why I used here this custom one. We're using this now for the response. For this partial one with this Markdown. So let's see the difference. For example, what breeds don't need a lot of exercise. And yet get here this bolded text. This is already a nicer improvement, but the animation is not so fun. So how do we get that? You can use an animating property. When you specify what value, this needs to be equatable and non-nil. Right now I have an optional, so we create another sub view where I don't have a nil anymore, an optional anymore. So let's add this here. So this is a struct, streaming, response, view. This is of type view. So this is a similar type as before, just not optional. So then I can do this stuff in this view without the optional ending. And an animation for animation type and value. For example, you can say bouncy or you can make it slower for the partial generate result. And now we can use these. If I have partial, I can use my partial string. Let's see if we get some fancy animation. Scrolling down to dog reset don't bark. You see, it's not as choppy. They added some, for example, because now I add one text after another, you can use the newer content transition. For example, I think it per default is identity, opacity. This will now blend it in. And to see this better, I use ease in out with duration of, let's say, 2, so it gets even more smooth. It's probably way too long for something you would want to show. You see, it fades in. Definitely much better experience now with this animation. Okay, that was the fun part, and now we need to make this a little bit more workable, because I actually want to add these response to my response array, to my messages array. So let's have a look when I want to send a message. You saw there was a little delay in the beginning where it didn't actually show anything. And for this, I am going to set the response to true. When I have this is what I use here to show this progress view. Then when I'm finished here, so after the dot is responding is false, now I should have a little loading indicator. You see here, this is just over in the beginning. You can hide this as soon as you have some streaming output. The next important thing is I actually need to make sure I'm not allowing the send button when I'm already streaming. In the content view for this button, you see that I use this as responding to make sure this button is disabled. Now, because I made the session here private, the session has a streaming property. Let me just check. Session is responding. So you can also use this property to disable this button. If you don't do this, if you allow it to process further, you will get another error here which tells you you're not allowed to send multiple responses to the same session at the same time. That's why it's also either you disable the button or you're saying if it's responding is false, then I am here returning, just to make sure you're catching multiple, adding more safety guards. Additionally, you can say only if there is a user input we should do this. So this is guard, user input is empty, it's not proceeding. Then we are setting this to is responding, which starts the animation. I am here adding this to the message. And I also want this property here is user input is used for this field. I also want to set this to null. So let's just create a copy in self.user input so that I can say self.user input to empty. And here for my streaming response, I use the copy that I just made. So it sets it to empty again in the text field. So you don't see it down here. Then the last thing, after I'm finished, I actually don't want to, because if I now continuously ask questions, I want to keep track of my messages so I can save them to disk. So when I'm finished, I can create a new chat message that I'm adding to my message array. So it's the same as this one. Now only in this case, it's the assistant. I'm setting this here to the partial one that I had. And I set the partial one to nil. Let's try this again. Maybe I should change the animation. You see, I am changing the UI. This is because I need to actually do this. In chat view, each of these markdown texts from the messages array get this modifier, whereas the streaming response doesn't. So I also want to add the same modifier to this one. Additionally, now I have this jump between these two views because the scroll view removes one and injects the other, so you have a jump in the UI. So now we have this animation background. It did not mean more about these. So it should tell me more about these breeds. And you saw there was another jump. Okay, it did not want to tell me more about these. We have now a problem with the identity. I want this view considered the same as this one. The view ID is with the identifier. I have this for each with messages, the chat message type. The ID is used from the identifier by protocol, which is this ID. When I start my stream, I don't have an ID yet. I'm passing this. I create another property that keeps on where I track the partial ID, the new identifier. There's a bit of trick with this identifier, so this is just a UID, same type. Optional. So when I'm here, I generate this new UUID. And I'm here for this chat message, use the same so I can identify this. If I don't have one, I use a new one. And then I also set this here to nil. Okay, now that I have this partial ID, I need to use it to attach it to my view. In this view, I need to have this identifier. So this is partial ID, UUID optional. So I can attach this one to this one. Now I have some init errors for the preview and in content view. I need to pass this down, which I can get from the view model, partial ID. If I go then to chat view, where we've used these properties, I have here first this for each loop with these messages and the streaming response, the last one, the ID here is then the same one than the new message here. So the list should guess that they are the same and not create this jumping. The one thing that it gets confused is here because I still have this progress view, so I continuously show the progress also at the end of streaming. And to make this work, I need to only show, anyways, it's a better UX design, only show this progress indicator when I start processing, but I don't start streaming yet. So I removed it and set this as an else if statement here. So this should help with this jumping scrolling to have the correct identifying what views are the same. Now before I go, I want to also improve one more thing, because I saw that here with the animation of this streaming response, here this streaming view modifier, which adds this background color and some padding. This one is currently not animating because it's outside of the animation, so I'm moving this one into the streaming response before the animation, so inside of the animation. Now, this animation modifier works and it animates anything that changes because of this value, here this partial response, but only the ones that are inside this animation. So I always see these view modifiers as views stacked inside of views. So we have the markdown text that is surrounded by this opacity content transition, and then we have this response. So you can also move this one just for nicer changes. So now everything inside here is actually animated. Also the background. Let me just show you. So I take one of these responses. So we see first the loading indicator. Now it disappears and we have this nice border. And you see also the border is nicely animating now and there's no more jump. I can also try this with additional prompt. Are they good with kids? So again we have this. And then it starts to animate this in. It's finished, the send button is enabled, and you see it did not jump anymore. So sometimes with these identifying views, with the streaming, it's a little bit complicated, and that's what they actually said in one of the WWDC talks for the foundation models framework. The last thing which is important is what we do with this restart. This restart button is currently connected to my reset function. Now the thing is, if you restart, it does remove this messages user input is running to false, but the streaming still goes on because this lives in this task. Now how do I cancel this task? I need to first keep track of the task. So I start in my property declaration here to keep track of the streaming task. Then I can assign this reference here. In the reset, I can then say streaming task cancel. This will still keep on going for the last one. In order to stop this, I add another guard before I continue updating this. I am going to check if the task we are in is cancelled. If it's not cancelled, then we continue and we're seeing more output. So now it should be properly cancelled. The most important thing is when I reset, I want to start a whole new session. I also need to change the model and reset this with the same instructions. Each session has the prompts, instructions and responses. You can get this with the session transcript. So this is an array of all these entries that you can look at for testing, which I will use in the next tutorial when I talk about tool calling. You see actually, oh, now it called this tool, now it fetched this data, and now it's responding using this data. Okay. But I think we're already quite far. So you can again ask one of these questions. With this nice animation, we see then the final results and you can keep on asking questions. It did get another safety guard error. As you see, it hits this one quite a lot. It's one of the most annoying ones. But in this case, it used both of these. In the transcript, it has both of these. So it knows when I say continue, that it continues, that it should talk about Taiwanese. And then it gives me all this information. I can press restart, and we start a whole new session, so it does not know anything about the other things that I asked about before. To sum things up, we used the new foundation model framework to create a little chat app that helps you find your new dog. We had to create a session with specific instructions to make it respond only to our use case. We generated a streaming response to show this nice animation in the UI. So the user doesn't need to wait for the whole response to generate to see something. We keep track of each session and all the chat messages, which you could save on disk for each messages for later. We can stop our response and restart a new session. This is the end for this very long tutorial, but I really wanted to show you more details and give you more background information of how these models work, what are the requirements. In order to make this app better to properly answer, also for more advanced questions, in the next tutorial, we're going to talk about tool calling, how to use this in this app. So go ahead and watch that here. Thank you for watching. Until next time, happy coding.